Hello, my name is Greg and I'm a volunteer at Aerospace Bristol. The 24th of April is an important date for all astronomers. 30 years ago, on the 24th of April 1990, the Space Shuttle Discovery blasted off from Cape Canaveral, carrying the Hubble Space Telescope and delivering it safely into orbit. The Hubble Space Telescope is a joint project between NASA and the European Space Agency. The telescope is named after Edwin Hubble, who is considered to be the discoverer of the Big Bang theory of the evolution of the universe. The telescope is essentially a tube. It's 13.2 meters in length. Light enters the tube where it strikes a large concave mirror, which is 2.4 meters in diameter and weighs just over 3/4 of a ton. The light is reflected back onto a secondary mirror and from there onto an array of 6 different cameras and sensors. Think of the telescope as being about the size and weight of a single-decker bus. Hubble is currently in orbit 340 miles above the equator, travelling at 17,000 miles an hour. Its cameras can lock onto a target about the width of a human hair seen from a mile away and are sensitive enough to detect a candle flame on the moon. The telescope is powered by solar panels, the wings that you can see on the side of the spacecraft. These were designed and built here in Bristol at the space division of what is now Airbus. This picture shows the solar panels undergoing a deployment test at the Filton Space Centre. Filton was also responsible for the design of the photon detector, part of the faint object camera shown here undergoing testing at the Space Centre. Let's look at some Hubble images. This is Jupiter, the largest planet in our own solar system. Notice the great red spot. This has been observed by astronomers for over 300 years. What we now know from Hubble and from other missions is that this is a storm, similar to a hurricane here on Earth. However, it is much larger. Earth could easily fit inside it. The winds inside the great red spot travel at over 300 miles an hour. Hubble takes images of Jupiter every month to monitor its cloud formation. And it seems that recently the red spot is starting to decay and get smaller, spinning off smaller tornadoes from its edge. Around the north pole of Jupiter you can see glowing blue lines. These are an aurora, just like the northern lights here on Earth and formed in the same way. Charged particles from the Sun are captured by Jupiter's magnetic field and drawn into its atmosphere, making the gases there glow. The blue colour is due to ammonia gas. Using the colour of glowing gases to determine their composition is a common technique in astronomy and is called spectroscopy. This is the Crab Nebula. It's 6,500 light years away from Earth and is 5.5 light years in diameter. What you're looking at is the remains of a dying exploding star, a supernova. This was first detected by Chinese astronomers in 1054 AD as a star visible during the daytime for 23 continuous days. When a star like this runs out of its hydrogen fuel, it firstly expands, then it becomes unstable and explodes, converting the hydrogen into heavier elements like oxygen, carbon and iron. The coloured filaments you can see are made up of those elements. As far as we know, this is the only process in the universe that creates these elements. All the atoms in your body started out in a stellar explosion like this. We are all made of star stuff. The inner core of the star would then collapse under its own gravity to a sphere about 20 miles across, squeezing all the space out between the atoms. This is known as a neutron star, and these are incredibly dense. A teaspoon would weigh about 100 million tons. We also know that neutron stars spin very rapidly. In the case of the Crab Nebula, for 35 times a second. The star was originally about 4 times bigger than our own Sun. If it had been bigger, the collapse would not have stopped as a neutron star. The core would have continued to collapse under its own gravity, getting smaller and smaller, and its gravity getting stronger and stronger. Eventually, the gravitational field would become so intense that nothing could escape from it, not even light. This is a black hole. So this picture is about a dying star. This is the opposite, a stellar nursery. Known as the pillars of creation, this cloud of hydrogen gas and dust is 6,700 light years away. Each pillar is around 4 light years in height. Gas and dust will slowly be drawn together under their own gravity until they become large enough and hot enough for nuclear fusion to start and the star to be born. The bright dots you can see in the clouds are new stars being born in this way. This is galaxy M31, better known as the Andromeda Galaxy. It's our closest galactic neighbour, just 2.5 million light years away. It's a very similar spiral galaxy to our own Milky Way. It's 110,000 light years across and contains around 1 trillion stars. Hubble, in partnership with the Chandra X-ray telescope, has discovered that there is a supermassive black hole at the centre of Andromeda. It has a mass of about 200 million times the mass of our own Sun and powers the whole galaxy. Further observations suggest that the vast majority of galaxies have a supermassive black hole at their core. This is probably the most important image ever produced by Hubble. It's known as the UltraWide Field. Astronomers pointed the space telescope at an empty portion of sky in the constellation of Sagittarius and took a series of long exposure pictures over a period of 4 months. This was the result. The coloured dots are not stars, but galaxies, and there are around 10,000 galaxies in this picture, and each one of those contains around 1 trillion stars. If you look closely, you will see some of the galaxies are very faint and red in colour. We know these galaxies are very old and very distant, around 13 billion light years away. They were formed shortly after the Big Bang occurred some 13.8 billion years ago. Hubble is currently searching galaxies for traces of black holes, and this image is an example of that. It's not possible to view the black hole directly, as it will just absorb any light, but these circles, known as Einstein rings, show that there is a black hole in the centre of this image. As predicted by Einstein's theory of relativity, light from a star can be bent around a black hole by its massive gravitational field. This is known as gravitational lensing. If we subtend the light rays reaching us here on Earth, the effect is of a ring, just as we see in this image. Gravitational lensing has been developed by the Hubble team and now is an important tool in the studying of the universe. The Hubble Space Telescope has now been in orbit for 30 years, well beyond its sell-by date. It's due to be replaced by the James Webb Space Telescope, which is scheduled to be launched next year. In its many years of exploration, the Hubble Space Telescope has produced many exciting and beautiful images and has increased our understanding of the universe in which we live enormously. When the Aerospace Museum reopens, there will be a lunchtime lecture on the Hubble Space Telescope. Keep an eye on the website and social media for details.